my pleasure to introduce our first speaker today, Professor Mahmoud Abdelat, and he'll speak on recent advances on quantum computation.
Thank you so much. Thank you. Good morning, everyone. In fact, I'm very pleased and honored to be here in this wonderful conference and to see a lot of my friends from Africa to see here in China. So thank you so much for the organizing committee and everyone who has a role in conducting such an interesting conference. Today I will speak about some issues, just a basic idea about quantum computation and quantum computer and what happened during the last 10 years in such a field. Before I start, just we came from African Mathematical Union, and African Mathematical Union, to just give a brief about African Mathematical Union, we have this, it's a Pan-African organization, represent all African continent. For example, we have a GC committee, and also we are happy to have, he is the president, Busoto, he is the president of African Mathematical Union, just he elected 2 years ago. And every region we have a vice president, we have 5 regions. So I am a vice president for North Africa, and we have 4 Tanzania, also East Africa, and Professor Makini for South Africa. And I have so many colleagues here from South Africa today, and also for Western Africa, and finally we have Professor Shabani for Central Africa. He's from Burundi. And the former president, Nosaliaku from Mura. That's the GC, and we have election each 4 years. China-Africa collaboration, in fact, I am very lucky because I have a long history with African and China collaboration. I have colleagues from China, and we have a very fruitful collaboration. For example, I started 10 years ago with Professor Zhengyang. We have a collaboration in our research work, and I represent 3 countries at the same time, where I am originally from Egypt, and I am working in Bahrain, and affiliated with Abu Dhabi University, United Arab Emirates. So usually I go to see affiliation in my work. And the funny thing, we started collaboration with Professor Zhengyang 10 years ago, and we have published a large number of papers together. It's more than 100 papers in a top journals. But the first time to see each other last year in this university. Yes, I visited the university last year, and I have seen him for the first time. That was fantastic. And also, I have a collaboration with Professor Yu, and we started our collaboration, and we published now together. And our collaboration expanded to have so many different activities, like conferences and joint projects. We applied together in this national project here in China together, and so on. And also, I have a collaboration since more than 10 years with my colleague Xiang, and we have published in 2019 a very interesting paper and new model, and now it's called like Young Abdelati Carlo. We are 3 persons in this paper, and become highly cited paper. So this is my collaboration with my Chinese friends, and I hope with this conference also we will create a new collaboration with a new colleagues from this university and other universities. We didn't stop in a collaboration in just writing paper together, but we have conducted in Egypt international conference together. my university and this university, your university, here last year, and I have some from your university. They visited us in Luxor. It was 4 days, very beautiful 4 days, because Luxor in Egypt is a historical place, and we enjoyed discussing mathematics and also visiting the place. So I have these speakers in the conference. We have Yediga, who gave online lecture, and we have 2 also, they visited us with the student. Some students also, they came to join us in this conference in Egypt last year. Okay, and this sample of our product and publications, just we published this, published in IEEE, which is a high journal, and this one, for example, in Express System with application. And just I wanted to give you a brief about my collaboration with Chinese colleagues, which I like it very much, and I feel great honor to continue such a collaboration with them. In fact, it's easy and very interesting to have such a collaboration. Nothing we can say, there is no problem, or what is it? That's okay. When I now switch to my subject, so I will speak about quantum computation, quantum computer. In order to speak and to understand the main idea of quantum computing, we started from the binary system, a binary system which is 0 and 1 that we are using nowadays everywhere. 0 and 1, and we just construct the processor for a computer from electric circuit like this, and when it's open, it gives me 0. When it closed, then the current will move and give me 1. So we have only 0 and 1. But here in the quantum one, we have what we call it a qubit. And a qubit, just we have it's the same classical model. We have 0 and 1, but here we have ground state and excited state. Ground state we can call it like a 0, excited state we can call it 1, and between 1 and 0 we have a large number of probabilities. So we have what we call it here superposition. Superposition principle here in quantum does not exist in classical. So we can have, using quantum principle just simple as it is, we can have a large number of probability at the same time. So we have a faster processor, we have a faster operation than the classical. It's exactly can be represented in this way. Rather than 0 or 1, we have here negative psi equal alpha equal 0 plus beta equal 1, and when we change alpha and beta, we have a new probability. And even alpha is it's a complex. So also we can have a different probability changing all these factors, and what we call it qubit, quantum bit, rather than bits 0 and 1. And here's the quantum computer. Just this is sample quantum computer in lab. And we can say, okay, the first qubit, how we can find the qubit. And the first experiment that gave me this, the normal reservoir and normal island, and between them there is a tunnel, and when the electron move from left to right and come back, it gives me exactly the same operation like 0 and 1, and gives superposition. So when we think about creating such a qubit, we thought about what we call it copper pair box. Copper pair box because it's superconducting materials, and superconducting materials has its own properties. The electrons goes in 2 by 2, not only 1. And this is the first one, the first material that we could create the qubit using such experiment, small experiment.
What exactly a qubit?
Qubit quantum bit.
Yeah, what exactly it is mathematically?
Mathematical, this one.
It's complex numbers.
Yeah, I will show you. This one exactly. This one. This is a qubit, mathematical.
Two complex numbers.
Yeah, to combine. So the combination, the difference between, I will tell you, the difference between classical computer and quantum computer. Classical computer, we have this classical computer that we are
Yes,
using
but
now.
how do you represent the complex number in a computer?
I will tell you now. We have an input, here we have an input in this computer from the keyboard or from the mouse. Then you have input. And then you have operation inside the computer in a processor. And then the output will be on the screen. We will see on the screen. This is in a class. Any quantum, we go to the quantum. We have a physical system. Physical system interaction between, for example, a laser and superconducting material, laser with molecules, or any physical system. This what we call it a quantum, this is the input, initial state. We have initial state from interaction between field and atom. Say, and then according to the quantum law, this operation will happen, and then finally we have the output, we call it final state. Final state, we have here, we measure a final state according to the quantum, not a classical. If we apply classical, we can not say how we can input, for example, a complex number in a computer. No, we have a physical system.
It will be important when you will pass from classical to quantum.
Yes. I will show it in my presentation. I will show it. At the end of my presentation, you will see how we can get a classical, because we need a classical. We cannot say, for example, yeah, we have operation from quantum in order to, for example, store information or send information. Okay. So in order to build the quantum computer, we need a multi-qubit. And to have a multi-qubit, we should use a different large number from copper boxes and connect it through the nano wires, and then we will just construct this quantum processor. And nowadays there is some companies we will also mention later. They could produce more than 150 qubits, which is a very fast quantum computer till now. Okay. There is a very important book, what is called the Quantum Technology, Our Sustainable Future. Really, quantum technology can solve a huge number of problems that we cannot